Hello and welcome back to another video. Here in this video we are going to discuss the next two questions from Pure Mathematics 3 Specimen paper 2020, and here is the 7th A question. By first expanding cos x plus 45 degree, express cos x plus 45 degree minus root 2 sin x in the form of r cos x plus alpha, where r is greater than 0 and alpha is in between 0 and 90 degree. Give the value of r correct to 4 significant figures and the value of a correct to 2 decimal places. So this, by first expanding, we are going to expand by the formula cos of a plus b. That is the identity here. This is the expansion of cos a plus b, and here we have a as x and b as 45, so we can write it as cos x plus 45 degree as cos x into cos 45 degree. Cos 45 degree is 1 over root 2. From the calculator we can get it as 2 over root 2 also. Root 2 over 2, that's the same thing, because 1 over root 2 can be written as by multiplying by root 2 and dividing by root 2. We'll get it as root 2 over 2. So by calculator we get root 2 by 2, but anyway cos 45 degree is 1 over root 2 minus sin a means sin x into sin 45 degree, that is again 1 over root 2. So we can write this cos x plus 45 minus root 2 sin x. We can write minus root 2 sin x here, so we'll subtract root 2 sin x here as well. So we can see sin x, so we'll add the like terms and we can write it as 1 over root 2 cos x and minus 1 plus 1 over root 2 plus root 2 and sin x. 1 plus root 2 over root 2 is going to be 3 over root 2. Root 2 into root 2 is 2 plus 1 3 over root 2. So it can be written as 1 over root 2 cos x minus 3 over root 2 sin x. So we want to write this as r times cos x plus alpha. We can see it is negative, that's why it is cos, like whenever you have a plus b we get negative here, so we are going to take this as alpha r cos alpha and this as r sin alpha. So it is 1 over root 2 would be r cos alpha and 3 over root 2 as r sin alpha, so that we can compare these two to get x cos of x plus alpha. So for that we require this as cos alpha, first constant, and then another constant as sin alpha. So we have taken it as r sin alpha. So from here we will square and add, we will get 1 over 2 plus 9 over 2 as r square cos square alpha plus r square sin square alpha, and we know the identity cos square alpha plus sin square alpha is 1 for all the alpha, so we got it as r square, means it is going to be 10 by 2 5, it means r equals root 5. And since we need to give the answer till 4 significant figures, and from calculator we will calculate this root 5 is 2.236. this is correct to 4 significant figures. And for for alpha we are going to divide r sin alpha by r cos alpha, so we will get tan alpha as 3 by root 2 upon 1 by root 2. Root 2 got cancelled and you got 3, means alpha is tangent inverse of 3, and since we require it in the degree, so we will do our calculation in degree. So tangent inverse of 3 from calculator is coming 71.565, and we require to write till 2 decimal places, so it is 71.57, and that's the answer in degree. And of course we can see this alpha is in between 0 and 90 degree, so we don't have to find the other alpha. I hope it is clear. Let's do the B part of this question. And here's the B part of this question. Hence solve the equation. If it is hence solve the equation, we are going to use the first part, answer of the first part. And from the first part we have seen that this left hand side can be written as r cos x plus alpha, and there r was root 5, and it is root 5 cos x plus alpha. Alpha is 71, it was 71.57, but we will take alpha and we will write the last value, or we will find the x. When we will write the last answer of x, we will include the 71.57. So from here we got it as root 5 cos x plus alpha as 2, because left hand side become this, equals to, it means from here we can calculate x plus alpha is going to be 2 over root 5. We could have also written this root 5 as 2.236 till 4 significant figure, but that's fine, because calculator will calculate the rest of the value, because we are going to calculate the angle, and here the angle is not only x, the angle is complete x plus alpha. So from here the x plus alpha would be cosine inverse of 2 over root 5, and we are going to get this as cos inverse 2 over root 5, and this value is 26.565. I'll write till 3 decimal places. And here we need to get the x value. We can see it is x plus alpha, x plus 71.7. So we can check from here that till what point we can go for the next values of the angles. So x plus alpha would always be more than 71.57, because it was 0. I'm adding alpha on both the side, and here 360 plus 71.57. So it is going to be 431.57 degree. So we can see that this angle will ignore, because it is not lying in between. So for the next value, we know for the cos, the next value of the angle is, we get it by theta minus 360 degree minus theta. So it is 360 degree minus 26.565. So 360 minus 26.565 is, this value is coming 333.435. and next value again, because we can see it is still between this 71.57 and 431.57. So we can again calculate the next value, and angle value is always going to be x plus alpha, and this next value would be 360 plus the angle, that is 26.565, and this value is going to be 386.565. And now if we'll find the next value again, it would be the 360 plus the previous angles, which will be more than 431. So we are going to stop here, and from these two values we will get the x value by replacing alpha by 71.57. So from the first one, x is 333.435 minus alpha, that is minus 71.57. This value is coming 261.86, and this is the angle, so we'll write till 1 decimal place. It is going to be 261.9 degree, and from the second one we will get x as 386.565 minus 71.57. It is going to be 314.99, so it is going to be 315.0 degree or only 315 degree. So these are the two solutions. I hope it was of some help. Let's discuss the next question. And here's the question number 8. Sorry. So in the question number 8, we can see it is in a diagram OABC is a pyramid in which OA is 2 units. This is 2 unit. OB is 4 unit and OC is 2 unit again. The edge OC is vertical. The base OAB, it is base, is horizontal, and angle AOB is 90 degree. And also otherwise also it is IJK, so they are perpendicular to each other, so that would be, this is also going to be 90 degree, this will also be 90 degree. And next, unit vectors I, J and K are parallel to OA, OB and OC respectively. The midpoints of AB is M, so these two are equal, it means, and BC is N is the midpoint of BC, so this would also be equal to each other. The first part is express the vectors ON and CM in terms of I, J and K. So let me draw the vectors first. So we can see the vectors ON, this is ON vector and this is CM vector. We are going to write it. From here we can see OA is 2 unit and one unit vector is I cap here. So OA vector, from here OA vector would be 2 I cap. Similarly OB is 4 unit, so OB vector would be 4 times its direction, the unit vector parallel to that, that is going to be 4 J cap or only 4 J. And OC vector, that is the OC is 2 units, so OC vector would be 2 K cap. Now we want ON vector, so ON, we can write ON as, we will go from O to B, and then plus half of B to C, because N is the midpoint, so half of BC vector. And OB vector is 4 J cap plus half of BC vector. So B to C vector is B to O, that is going to be minus times 4 I cap, 4 J cap, because this OB vector is 4 J cap, it means BO vector would be minus 4 J cap, because we want to find BC, to B to O and then O to C. O to C is 2 K cap. Now we are going to simplify. We can see it is minus 4 by 2, minus 2 and plus 4, so we will get 2 J cap only, the 2 J vector, and 1 by 2 into 2, that is going to be K. Similarly we will calculate CN vector, CM, C to M. So we are going to find the path. So from C to M we want to go, so first of all we will go from C to O, then O to A, C to O this direction, and then O to A, and since M is the midpoint, so it is half of the total vector AB. So C to O, O to C is 2K vector, so C to O would be minus 2K vector, 2K now, and plus OA is 2I plus half of AB vector, A to B, so A to O is minus 2I and O to B is plus 4J. Now it is 2I and we will simplify this I, 1 over 2 into minus 2 is minus 1, so it become only 2 minus 1, that is I only, and then 1 by 2 into 4 is going to be 2, so it is plus 2J, and here it is minus 2K, which is unharmed, so it is minus 2K. and this is going to be CM vector. That's it. I hope it is clear. Let's discuss the next part. And here is the P part. Calculate the angle between the directions ON vector and CM vector. Since we are talking about the angles between the directions, so it does not matter where this vector lies, because vector of equal magnitude and same directions are always going to be equal. So it does not matter if you are drawing this vector here or here. So ON vector, from the previous part we have seen it is 2j plus k vector, 2j plus k, and CM is I plus 2j minus 2k from the previous part. So now if we have the vectors, we know if we have vector A and B and we want to find the angle between them, so it is defined by this formula, dot product A dot B is magnitude of vector A into magnitude of vector B and cos of the angle between them. So here we are going to calculate ON dot CM first, and it is going to be, it's like here is no I, so it is 0 to 1, and dot product with here 1 to minus 2. It is going to be multiplied component wise. 0 into 1 is 0, plus 2 into 2 is 4, into 1 minus 2 is minus 2, so it is 2. And ON modulus is magnitude of ON is going to be square root of component square, sum of the square of the components. So 0 square plus 2 square plus 1 square, it is going to be root 5. And CM modulus is square root of 1 plus 4 plus 4, it is 4, 4, 8, 1, 9, so it is 3. Now the angle cos theta, from here we can say that theta is the angle between them. So cos theta is going to be dot product between them, that is 2 over multiply by their multiplication of their modulus, that is root 5 into 3, 3 into root 5. So from here we will calculate theta. This is going to be cos inverse of 2 over 3 root 5. Now we will calculate its value. Cos inverse of 2 over 3 root 5, and this value is coming 72.65 and 3 and so on. So we can write till one decimal place, that is going to be 72.7 degree. So that's the angle between the directions of ON and CM. So I hope it is clear. Let's do the last part of this question. Now here's the last part, C part of this question. Show that the length of perpendicular from M to ON is 3 over 5 times root 5. So let me bring the diagram here so that it will be clear. So we need to drop a perpendicular from M to ON, and then we'll see its length. We'll find the length of it. That's the length of perpendicular from M to ON. So let me drop a perpendicular on it. Now here's the perpendicular I draw. Let's say this, of course this angle would be 90 degree. I'll mark this point, any point on this, as B. So in this type of question, first of all we'll take a general point on ON by the equation of line of ON, and then we'll find the vector PM, and then we'll take the help of dot product of vectors perpendicular lines, that is ON and PM, and we'll take a dot product. It would be 0. From there we'll get an exact value of P, and hence we can find the exact PM vector, and then we'll find its length. So let's start with the first step, that is equation of line ON. So equation of line ON, we always write the equation of line as R equals A point on the line plus T times vector B, that is a direction vector. Here A we can take as origin, because this would be very helpful, 0, 0, 0. So the equation of line ON become 0 0 0 plus t times, so it is t times, and b vector means parallel vector to this direction, and ON itself is a parallel vector to line ON. So from the first part we have seen it is 2j plus k vector, 2j plus k. So in general, any point on line P, so from here we can take P as any point on this, because we can write it as t times 0I plus 2j plus k. So any point on the line ON, we can take it as 0 plus 2t plus t, sorry, not plus, it is the third k coordinates is going to be t here. From here we decided it is going to be 2t and t. We could have taken lambda also, that's fine. So now if we have p, it means we have OP vector. OP vector is 0I cap plus 2t j cap plus t k cap. And now if we have OP, now we'll find PM vector. PM is going to be P to O, then O to A, and then A to M vector. Now we will calculate. P to O is the negative of it, so it is minus 2tj plus minus tk. OA is plus 2I cap plus AM is half of AB, and we know that AB vector is going to be O to A, that is 2I minus 2I plus 4j, because this will be going this way and then this way. So half of it would be minus I plus 2j. So we will solve it. I cap with I coordinate is I component, it is going to be only I, and then j, it is 2t as well, so it is I'll take 2 common, 1 minus tj, and for k it is unharmed again, minus tk. So this is going to be PM vector. Now we know that PM and ON, they are perpendicular. It means they are dot product. ON vector dot PM vector would be 0. It means PM, we know ON is 2j plus k, so we'll take the dot product of these two. So I component into I component, it is 0 plus 2 times 2 into this, so it become 2 times 1 minus t plus k component minus t equals 0. So from here to 2 is a 4 minus 4t minus t equals 0. It means we got it as 4 equals 5t or t equals 4 over 5. Once we got t equals 4 over 5, now we can write what is PM vector. So PM vector become I plus 2 times 1 minus 4 by 5. 1 minus 4 by 5 is 1 by 5. So it become 2 by 5j minus 4 by 5k. So we have PM vector, and hence the length of perpendicular, required length, is going to be square root of modulus of PM. We'll write it here. PM vector, modulus of this is the required length. It is going to be 1 plus 2 by 5 square is 4 by 25 plus 4 by 5 square is 16 by 25, and we'll solve it. It is going to be 45 over 25, and 45 over 25, it can be written as 9 into 5 over 25, So 9 and 5 are square numbers, so it become 3 by 5 times root 5. Hence it is done. So that is what we need to show, and that's it for this video. I hope it was of some help. Let's discuss the next few questions in the next video. Till then, thank you so much.